Looks like we're live. Hello and welcome to a new episode of ZomCast. ZomCast 11, November 6, 2020. And we are in the middle of US presidential election. But it has nothing to do with our podcast and with our topic. I'm Mehdi and I'm the host of this podcast. And I'm here with my co-host.
Hey guys, I'm Mahmoud. I'm co-host of ZomCast.
All right. Do you know what we are going to talk about, Mahmoud, today?
Quantum computing?
Yeah, we are going to talk about quantum computing.
Great.
And although it's a great topic, we are not great experts in the field. But I'm just curious about quantum computing myself and had some little study about it. And earlier this week, I read an interesting article on nature.com from, let me say, which author. Yeah, Peter Shor. He's a distinguished doctor. He's a distinguished professor, if I'm not mistaken, maybe from MIT or some other famous institute. And I think in 1990s, he published an article, and in that article, which was about quantum computing, he proposed a novel way, a new and modern way of using quantum computers and quantum computing to solve mathematical problems. So, first of all, what is quantum computing? Let's talk about this a little bit. Quantum computing, I'm not a physics guy and I don't know a lot about its physical aspects, but it's a field of physics, I guess. It deals with particles and physics, and it's a technology that is based on that. So I don't want to delve into, because I don't know much about it, I don't want to delve much into its inner working and how it works under the hood. But in short, quantum computing works based on quantum theory in physics. And you might think that it's a very new thing, that the quantum theory is going to be used for computing, but that is not the case. Actually, the discussion about quantum computing and its potential for calculation and computation is as old as maybe 1970s.
Wow.
Yeah, in 1970s, from 1970s, some scientists have been thinking about it and suggesting that quantum computing might be very useful for calculation and very effective and even much, much faster than classical computers in terms of computation. But, and this is a big but, why? Because quantum computing has a problem. Due to the nature of quantums, or they call it qubits, the bit equivalent of calculation, of computing, the bit equivalent of computing in quantum computing is called qubit. Due to their nature that is unstable, it's hard and it's challenging to save the state of quantums and the state of information that you are working on. So although it is very fast, it's super fast in comparison with classical computers, but you cannot save the state of your calculation. So it needs some kind of error correction. And the article I told you about earlier in this podcast from Peter Shor is just about this. Actually, he has found a way to more effectively solve that issue and uh, actually correct the errors that are on the way of calculation when using quantum computing, and it's super fast. So it's as old as 1990s, this article, but the reason why it is more focused and it's talked more about nowadays is probably due to the fact that people are more interested in having faster computers. And I think, Mahmoud, I saw some piece of news that Google recently did an experiment on using quantum computing. Google, in association with NASA, did a calculation, which was not very public, by the way. They claimed that they have done a computation, sorry. Calculation, when you say calculation, you automatically think of some manual adding with your fingers. Yeah. But computation. Google claimed that they did a computation that is way faster than classical computer and even infeasible, I think. Even infeasible on classical computer, on any physical computer. So, did you hear about that, Mahmoud?
Yeah, I hear about that.
Yeah, Google as one of the uh, uh, as one of the pioneers of many of the technologies that has also been active in this field, and they are trying to come up with new horizons in terms of quantum computing. Before we wrap up our discussion about quantum computing, let's also talk a little bit about the challenges that it creates. Imagine quantum computing works, and imagine it is active, it's operational, and it's ready to use today. It might have some problems, and one of the important problems that it might create is that it's super fast and it calculates everything. So when for example, a quantum computer can solve something, let's say, some integer factorization that is way, way slow on classical computers, even supercomputers, like getting the factors of integer numbers for doing RSA encryption, uh, getting the primary. Do they call primary numbers? Prime numbers, sorry. They get the factors, do prime number factorization, and it's super slow on classical computers. And these very big prime integers are actually produced by classical computers to do RSA encryption. So imagine today that quantum computing is operational and it is working, and some hackers have access to it. So they will be able to easily calculate RSA prime numbers and hack into all your communications. So this is, if you think about it, it's going to be a big problem,
Exactly.
and it's going to undermine every encryption technology on the web. I'm not much familiar with encryption technologies, but I think RSA is a very important one of them, right?
Yeah, exactly. Also is one most important encryption.
Oh, it's the most important
One of the most
one of the most
yeah,
important encryption technologies.
it's a big problem.
Yeah, RSA. So when RSA breaks, probably your communications are going to be broken, and a scientist will have to find another way to actually secure your online communications. But the fact, if we want to be more realistic, quantum computing is not that cheap nowadays. Actually, it's not cheap at all. It's very expensive and it's not operational yet. So scientists have to work more on it, but it's good to know about that, and it's good to uh, track its progress and see how it goes. Maybe we are close to opening ourselves to a new horizon of computers, a new generation of computers that just mind blowing and destroy all our imagination of computers that we used to have in the past, because they are just using a very different technology. All right, if you want to know more about quantum computing and the scientist I told you about, Peter Shor, please go to nature.com and then look for this article, Quantum Computing Pioneer Warns of Complacency of Internet Security. This is a very interesting article for everybody that has little or much information about quantum computing. I'm sure you will enjoy this article if you haven't already read it. So, this week's episode is going to be short, so we are not going to take much of your time. Before we close this episode, let me mention some news, some technology news of the past week. We had Fedora 33 released last week. Actually, maybe the week before last week, October 27. Today is November 6. Yeah, maybe the week before last week. But we had Fedora 33 release, and it has the latest software packages, as Fedora is always famous for. The latest open source technology is bundled for development in this version of the OS, and also a new disk management and a new storage system. I think it's Butter file system. Yeah, it's Butter file system, BTFS, something like that. Sorry for not being very accurate on this. Please go and check it out yourself. It is included and is the default file system. So if you want to upgrade from a previous release, probably you need some precaution. Probably you need to be more careful, like backing up your files or just doing a fresh install rather than doing place upgrade that has been very easy and successful over the last few releases. And we also have uh, coming ahead of us .NET Conference 2020. It is going to be held between November 10 and November 12, from November 10 to November 12, and for .NET lovers, including Mahmoud, it's going to have the .NET 5 launch.
Oh, yeah.
Yeah.
A lot of things I should.
Yeah, .NET Conference 2020. Make sure you tune in, and it's going to be virtual. And the last thing, but not least, is .NET Learn Challenge that is held for .NET lovers, people that want to learn .NET and C# using .NET. It is held between November 1 and November 29 this year. So if you want to learn more about these events and this challenge, please go to .net. Actually, it's a little bit interesting domain name, www.dot.net. Yeah, go check it out and see it for yourself. Thanks for having us. Thanks for listening to our podcast. I hope you enjoyed it. And if you liked it, please hit the like button, subscribe to our channel. Let us know what you think of the content of this episode and other episodes that we publish. And stay safe.
Thank you, guys.
Take care
Goodbye.
and
Goodbye.
goodbye.